In 1944, there was chaos in the land. Fire brewed like a fierce tornado and threatened to swallow all who were involved. The deadly D-Day landings in World War II were just around the corner, and this meant doom for the unprepared. But beneath the surface mask of despair, no one knew this. The Allied powers had something up their sleeves. Operation PLUTO. This is the story of the 500-mile-long secret hidden under the sea. From 1939, a disastrous war raged on between the Allied powers and the Axis powers. What seemed like a group of happy countries after signing the peace treaty from World War I soon turned into a mix of dissatisfaction, revenge, and expansion plans. Each side wanted the whole pie, and this signaled trouble. Despite signing a non-aggression pact, Germany, under the leadership of the infamous Adolf Hitler, pulled the first trigger by invading Poland in 1939, breaking their pact and making way for one of the most catastrophic wars in history. In no time, the opposing sides were formed. The Allied powers were a fierce combo of the United Kingdom, the United States, the Soviet Union, China, France, and many other countries lending their support in the form of supplies and public trust. On the flip side, the Axis powers did not consist of as many countries, but they were quite scary all the same. The Axis powers consisted of Germany, Italy, Japan, and a few other countries offering their support, mostly through the use of force. The stage was set for bloody warfare, and each mini-war within the bigger World War II spelled disaster for the involved parties. By 1942, Nazi Germany had dominated most of Europe, including France, which was a major support territory for the Allies. Infuriated to the bone about how stifling the supply of industrial resources from Europe would be because of the Nazis' invasion, the Allies had had enough. They mapped a plan and tagged it the D-Day landings, or more relatable, Operation Overlord. This operation was scheduled to kick off strategically, with the Allies wreaking havoc on Nazi-occupied Europe in different landings and invasions, going as far as deceiving the German intel to get the wrong locations. Everything seemed like a perfect plan, until they realized one flaw that Nazi Germany knew too well. How would they land successfully in Europe? The opposing limitations were too preposterous, from needing a battalion of soldiers and vast artillery to the logistics of supplying fuel needed to keep the modern artillery in check. Everything seemed bleak until Operation PLUTO came to light. This is the story of how the Allied offensive constructed one of the greatest engineering inventions of all time. This is Operation PLUTO, Pipeline Under the Ocean. Get ready, as we're about to dive into the interesting facts about this project and how it shaped warfare for good. The challenges faced by the Allied offensive kept increasing by the day. First, they needed a vast battalion of soldiers and amphibious vessels to stand a chance against the Nazis. Despite the support of the major countries in the Allied power, the task still seemed impossible. If they succeeded in moving that many soldiers and artillery to Europe without a hitch, they faced the opposition of the great German Atlantic Wall, which was formidable in every sense, with well-trained soldiers guarding the location and state-of-the-art artillery well positioned to send any form of resistance to the grave. But even this was a lesser problem for the Allies. If they managed to magically find a way around the formidable German wall, they still stood at great risk of losing because of a bigger reason: the logistics of supplying their army tanks and other artillery with fuel was alarming. How in the world were they going to do that without being destroyed in the process? Everyone knew that fuel was vital for the success of any warfare. The majority of modern artillery depended on massive supplies of fuel for their effectiveness. The Allies knew this, but so did the Germans, and they capitalized on this known weakness of the Allied powers. The Nazis decided that no one was going to supply the Allies with fuel under their watch, and they made sure of that. The Allies could no longer depend on the traditional methods of transporting fuel through tankers and jerrycans, as they were risky and insufficient for the scale of the operation. Building fuel depots on the ground was also a no-go, as they were vulnerable to enemy attacks from German aircraft. Since modern warfare depended heavily on fuel to work the tanks, trucks, and aircraft, crucial for mobility and firepower, there had to be a way. In addition, logistics like cooking for the soldiers and fueling generators in their camp made their desire to properly secure fuel for this big takeover soar to the roof. In the heat of the confusion and doubts about whether the Allies could even survive such a war, the solution was birthed. The Chief of Combined Operations in the Allied forces, Vice Admiral Louis Mountbatten, suddenly had an idea. What if we made fuel pipelines across the English Channel to sustain us? It was mind-blowing. He took this idea to Geoffrey Lloyd, who was the Secretary for Petroleum, and highlighted it as the much-needed breakthrough for the logistical challenge of supplying fuel to the advancing Allied forces in France. This was the beginning of a project that would change the way people saw military operations. This was the beginning of Operation PLUTO. But as beautifully mind-racking as Vice Admiral Louis' question was, it was not met with equal energy. Building a pipeline under the ocean at such a length was unheard of, and if they were to implement the idea, that would be the first. It soon became a case of be daring or fail while at it. Since Mountbatten was tasked with the responsibility of planning the Allied invasion of German-occupied Europe, the pressure to figure out the best way to transport the millions of gallons of petrol to Europe made him stick to his curious vision, and he pressed Geoffrey further. Not wanting to let the matter slide, Geoffrey Lloyd took the vision to his team of expert advisors to see whether it was feasible. Their negative affirmations were expected, and for good reason. Constructing a pipeline was not a big issue. After all, they already planned to depend primarily on the traditional methods of supplying fuel for the initial stages of the war. But as well as securing a safer method of transporting petrol, listening to Lloyd and Mountbatten meant that they were not only ready to build a pipeline across a great distance, but also facing the great currents and tidal conditions of the English Channel. And with no prior experience, the task was as good as dust to the experts that Lloyd consulted. This was the case until a man came into the picture. Clifford Hartley, the chief engineer of Anglo-Iranian Oil Company, was visiting the Petroleum Warfare Department when he heard about the pipeline proposal. To everyone's surprise, what seemed like a Herculean task was deemed possible by this experienced engineer. He had the results to defend his claims. During his time at the company, he had overseen various submarine pipeline projects, including one similar to the proposal suggested by Mountbatten. One of these Anglo-Iranian Oil Company projects was building a 3-inch pipeline that ran at 10,000 kPa. This pipeline supplied over 100,000 imperial gallons per day, which is the equivalent of over 20,000 jerrycans. Based on his experience with this previous project, he pitched his proposal on the 15th of April, 1942, asking to build something similar, but this time with core installations more suitable for the tidal conditions of the English Channel, and one that could evade both German aircraft and submarine attacks. However, it was not going to be easy. The concept of erecting such a magnanimous pipeline across the English Channel would require a perfect blend of planning, expertise, and unity. It was a bold and complex engineering endeavor needing all the support it could get to stand a chance against the finesse of the unrelenting German army. Chief Hartley aimed to build a pipeline similar to a submarine communications cable, but this time without the core and insulation, but with the armor to resist the internal pressures of the English Channel. From the pipeline design to the kind of material used and to the laying of these pipelines, Hartley turned what was a mere idea from Mountbatten into hope for the Allied powers. Maybe they did stand a chance after all. After getting approval from the chairman of Anglo-Iranian, William Fraser, and the other heads in charge, Hartley's proposal was codenamed Operation PLUTO, which meant Pipeline Underwater Transportation of Oil, or Pipeline Under the Ocean. That the project brought hope to the Allied forces did not mean it was going to be a walk in the park. The D-Day was fast approaching, and these pipelines had to be in place before the invasion of Europe. The Allies knew this and quickly swung into the planning and preparation phase for this first-of-a-kind pipeline. Operation PLUTO was entrusted into the hands of British Major General Neville Brown-John, the Chief of Staff to the Supreme Allied Commander Designate, or Cossack, alongside a bright yet diverse team of military officers, engineers and scientists from both the British and American forces, experts from the Ministry of Fuel and Power, representatives from the Anglo-Iranian Oil Company, and naval officers specializing in maritime operations were also not left out. Under the leadership of Major Brown-John, this team would go on to create the wonder that was PLUTO. In late 1942, plans kicked off in earnest. First, they needed to select and survey a route. Surveyors conducted a full-blown hydrographic survey of the English Channel, assessing the topography, depth, and composition of the seabed. This paved the way to identify the best route for the pipeline. The chosen route ran from the Isle of Wight on the British coast to Cherbourg, and later to other parts of Normandy in France. The route was picked because it minimized the distance while avoiding areas heavily mined or patrolled by German forces. But this was just one phase of the planning. Moving on, a key question popped up. What materials would be best for constructing these pipelines under the intense pressure of the English Channel? They needed these pipes to be both flexible and durable, but this proved difficult to combine in one material. The team decided to build two pipelines to this effect, one with beautiful flexibility and one with a strong and durable stance. To this effect, the HAIS and HAMEL pipelines came to light, with their distinct characteristics contributing to the overall success of the invasion of Europe. The HAIS, or HACE pipeline, named after Chief Hartley, was built to be flexible, consisting of an inner lead core for the actual transport of fuel. HACE was surrounded by layers of steel tape and covered with a protective sheath. This lead core provided the necessary flexibility to allow the pipeline to be laid across the seabed without breaking or kinking. To suffice for strength and durability, the layers of steel tape served as reinforcement for the pipeline against the pressures of the sea. The manufacturing process of this magnificent and flexible pipeline was not without its hurdles. It required that the lead core was encased correctly and the steel tape was wound tightly around it. Due to the urgency and great distance of this engineering edifice, just one factory could not keep up with the staggering demands of 30 miles per week. In no time, factories across Britain were repurposed for the massive production. The next query came up. How would they deploy these pipes, considering the urgency and secrecy involved? Enter the cable layers, specially adapted ships equipped with large reels to unspool the pipeline onto the seabed. They were used to successfully deploy the HACE pipelines under the decoy and camouflage formations of the Allied forces. The longest continuous section deployed was approximately 83 miles, laid from the Isle of Wight to Cherbourg, and, true to its characteristic features, The flexibility of Hayes pipelines allowed them to adapt to the contours of the seabed, making them suitable for areas where a rigid pipeline might break. On the other hand, the HAMEL or Hamel pipelines were built with materials to suffice for the strength and durability deficit of the Hayes pipelines, mostly consisting of steel pipes with welded joints to ensure durability and resistance to high pressures. The steel within provided a robust means of transporting fuel, albeit with less flexibility compared to the Hayes design. This made Hamel pipes more reliable. But getting that much steel at remarkable speed was a difficult task. Hence, factories were repurposed to serve as production houses for the mammoth amount of steel required to build Hamel pipelines. However, the installation process was even more perilous. These heavy and rigid pipelines had to be floated across the channel before they were sunk into position, and the pipes could not be dropped in just any manner. This method required precise coordination and handling to avoid damaging the pipes. Varying in different lengths with sections joined together, the steely, rigid nature of Hamel pipelines made them highly durable and capable of withstanding high pressures. This was critical for maintaining fuel flow over long distances. But merely producing the Hayes and Hamel pipelines was not the only major task the PLUTO team had to take care of. The factors surrounding their manufacturing, transportation, and secrecy had to be considered. For one, the project required the production of hundreds of miles of pipeline sections. This team mapped out plans for factories to be repurposed, and production was split between British and American facilities to meet the demand. Due to material shortages, innovative solutions such as using different insulation materials were implemented. For instance, steel shortages led to prioritizing pipeline production over other wartime needs. Still, this was not all. The German forces were known to always be on alert for any signal of progress from the Allies. This meant that the pipelines had to be transported to the deployment site in safe condition and without signaling German troops. To this effect, the team carefully scheduled and coordinated the shipping routes. In addition, specially designed vessels like HMS Conundrum were developed to lay the pipelines across the channel. These ships could carry and deploy long sections of pipeline safely and efficiently. To ensure the secrecy of the mission, the Allied powers created a broad decoy plan to distract the German troops and also get an edge on D-Day landings. First, they codenamed the broader strategy Operation Bodyguard. The next step was to divide this broader decoy plan into many parts, of which two sides were remarkable: Operation Fortitude North and Operation Fortitude South. Operation North was created to distract the German army into thinking that the invasion would happen in Norway. They did this by employing a fictional Fourth Army in Scotland, complete with fake radio traffic, inflatable tanks and dummy installations. Reconnaissance flights were dispatched over Norway to increase German suspicions, and it yielded results. Operation South sprung to the surface with just about the same effects. To mislead the Germans into thinking the main invasion would occur at Pas-de-Calais instead of the scheduled Normandy, the Allies established a fictitious 1st United States Army Group, or FUSAG, under General George Patton in southeast England. They employed fake equipment, double agents, and false radio communications to make this threat appear credible while maximizing the use of decoy landing crafts and dummy paratroopers to add to the illusion. This and many more decoy operations formed the bedrock for the successful security of the PLUTO mission, and week by week, the gigantic work of art came to life in the depths of the English Channel. During mid-1943, Operation PLUTO was in the works and was finally ready to test the waters. Bunkered deep in the English Channel, the question of whether this would be the saving grace of the Allied troops as they invaded Europe hung in the air. Was this mission going to be a success? There was only one way to find out. First, The prototypes of both the Hayes and Hamel pipelines were tested on land and in controlled water environments. The test for the Hayes prototype showed that the pipeline was flexible, consisting of lead sheathed with steel wire and asphalt, making it suitable for underwater use. The tests focused on flexibility, durability, and ability to withstand the marine environment, and it came out positive. Tests on the Hamel prototype focused on its structural integrity and ability to handle high-pressure fuel transport over long distances. The positive results from both pipeline prototypes paved the way for the next stage of trials. The next set of tests were full-scale. First in shallow waters, then in deep waters, the pipes were checked for factors like leaks, kinks, and buoyancy. These prototypes were tried under simulated conditions closer to those of the English Channel, providing data on how the pipelines would perform under increased pressure and temperature variations. But it didn't stop there. The next scale of tests would prove if the vision was worth pursuing: the pumping test. This trial phase answered the questions of whether the pipelines could withstand the pressure of fuel flow without bursting. Both on the seabeds and in controlled environments, pressure testing and flow rate trials were conducted on the pipelines. The trials progressed from pressure and flow rate testing to mock installation runs. At first, they tried the mock installation on land by laying out pipeline sections, connecting them, and simulating fuel flow to identify any potential issues. Once positive, sea mock installation runs were carried out to full effect. The remarkable team led by General Neville Brown-John left no stone unturned as they gradually moved the testing process from merely prototypes to full-scale testing, and finally to large-scale operational trials. The last major test was the complete deployment of a pipeline across the Channel. The small-scale deployments, which involved laying sections of pipes across the English Channel, had proved successful, and the large-scale test was the final straw. The pipeline was deployed across the English Channel and aimed to simulate actual operational conditions, including the coordination between laying ships, pumping stations, and support vessels. The results from each testing process went through rigorous sessions of evaluation by a team of experienced engineers, scientists, naval officers, and industry experts. More often than not, problems regarding leaks, buoyancy control, and balancing flexibility with strength were encountered and tackled. After countless trials and refinements, the final designs for both Hayes and Hamel pipelines were approved for operational use. Since all levels of tests were completed, confidence levels were high for the Allied forces. By the time the D-Day landings were in full surge, the pipelines were ready to support the invasion with a massive supply of fuel. On the 6th of June, 1944, it all began. What was conceived as a plan since early 1942 and gradually anticipated through the years was finally here. The D-Day landings, also known as Operation Overlord, was unleashed in its full terror, taking the Axis powers by surprise. Enforced by the coordinated efforts of the United States, United Kingdom, Canada, and other Allied nations, this was the largest amphibious attack in the whole of warfare history. The goal was simple: establish a solid foothold in Nazi-occupied France and kickstart the liberation of Western Europe. With 5 major beachheads mapped out as targets, over 156,000 troops stomped the feet of Normandy and caused chaos that had lasting impacts. But in all of this, the constant demand for fuel rose as the war advanced. In August of the same year, the pipelines were set off into the pressure of the English Channel. However, the Allies did not just lay out all their cards by constructing the full pipeline at once. They laid the pipeline section by section as they progressed into Europe. This strategy was employed to prevent German awareness or attacks to destroy their lifesaver, PLUTO. In addition, the incremental approach allowed engineers to address issues as they arose and optimize deployment techniques. Still, as they gradually approached their goal, they needed sources of fuel to maintain the fuel flow. To solve this, strategically positioned fueling stations were erected in key locations. These stations were located on both the English and French sides of the English Channel and equipped with powerful pumps to push the fuel through the pipelines over long distances. Near the beachheads on the French side, fuel depots were established to store and distribute fuel to the advancing Allied forces. The building process for these stations was even more intriguing. Late at night, the construction of the pumping stations drilled the ground. Equipment masked under tarpaulins was moved in secretly, and the stations were camouflaged to look like villas, seaside cottages, old forts, or any other innocuous, distracting features. Details regarding the Petroleum Warfare Department, or their initials, were banned from appearing on any package relating to this mission. With such skill and detailed instruction in handling the pipelines and their corresponding facilities, it's clear that the entire operation was a mark of expertise, collaboration, and security between the different sectors of the team to ensure its success. From its launch and first operation in August 1944 to its closing in August 1945, Operation PLUTO carried a staggering 180 million imperial gallons of petrol, which is approximately 820 million litres. On the 7th of August 1945, after the much-wanted victory of the Allies over Nazi Germany, Operation PLUTO was closed down to preserve manpower. Barely 2 weeks later, the system was officially disbanded, and the Petroleum Warfare Department packed up on 31st of March 1946. The need for the pipelines was accomplished, and the government saw no future need for the submarine fuel transport system. Peace treaties were signed already, so what was the use of keeping active weapons of war? Operation PLUTO, an idea conceived in the mind of one man, taken up by another who saw the possibility of the vision, and brought to life by the combined efforts of experts under the leadership of a resilient general. These men, Mountbatten, Lloyd, Hartley, General Brown-John, and the host of committed contributors birthed a monumental project that turned the waves of the deadly World War II in favor of the Allied powers. The legacy of this remarkable project lay in its ability to push the boundaries of existing engineering technology up until 1942. Hayes and Hamill showed innovations in flexible and rigid pipeline design, as well as the techniques for underwater laying. This influenced future engineering projects, from building subsea oil pipelines to establishing telecommunications cables. Post-war military strategies and civilian oil supply networks were reshaped to model advancements in pipeline construction and maintenance. More remarkably, the pride of Operation PLUTO was in supplying the Allied forces with enough momentum to fight the fierce battle to the end. This was the reason for its creation, and it was an undoubted success. The story of the mighty Operation PLUTO must be told with utmost respect, from the conceivers of the idea to the teams of engineers and naval officers who worked tirelessly to lay the pipes, and to the soldiers who protected their only chance of survival against Germany. The project is a testament to the resilient spirit of the fighters who risked their all in the world-changing World War II.